Hello dear friends, welcome to our program for chemistry, third secondary stage. Today we have an important session about what? About revision of chapter 3. Let's go to see the types of questions. Let's go to see how can we answer these types of questions in a right way in the exam. Let's go to start our session today. Revision chapter 3, we have electrochemistry that we make revision today about this chapter. It's very easy to know the question, it's very easy to know the answers about this type of questions. Let's go to see. First of all, we have, does the dissolved ionic compound conduct electricity? We have the electricity here. We have some kind of chemical compounds that we use to make electrolytes. So electrolytes, sodium chloride like this. Will an ionic compound conduct electricity when it's dissolved in water? Let's go to see. If I have sodium chloride here in ACl, if you put it inside a bowl of this one or a container like this, and we put some pools, two pools, one of them is positive and the other one is negative, and connected to the battery or power supply, and after that connected to the lamp, what will happen here? If I on or make on this one from or turn on this battery like this, what will happen here? Here we have the part of ions doesn't move, so the ions here doesn't conduct the electric energy overall of this one. Why? Because here these ions, it makes what? It's connect to each other very strong, so it cannot move in the solid. So the solids here, it cannot, or any compound or ionic compound in solid state cannot conduct the electric energy. After that, if I change this solid state and put it in some amount of water and stir it like this to make solution of the sodium chloride, and put the same two pools of the positive and negative, two pools of electric energy to make the electrolyte here. So the electrolyte, it can produce or can connect electric energy or not. So here we have what? We have this electric energy. If I turn on the battery like this, so the lamp will light up here like this. Why? Because the ions here makes what? This time when the current is switched on, the bulb is light. Why? Because this shows that the solution of sodium chloride does conduct electric energy. Yes, it connect electric energy. So here by the using what? By using the ions here. So after that we have ions of sodium chloride are free to move when they are dissolved in water. So it is very easy to move inside this solution and change or converts from positive pole to the negative pole to close this circuit between the battery, lamp and the solution. So NaCl in this type, or in this case, it's called electrolyte. What's meant by electrolyte? Electrolyte, it is a solution or a material that has free ions to convert the electric energy, to convert electrons from positive pole to negative pole, and make what? And make connection of electric energy here. And here we have the last part here, the green gas. It's formed, it's called, it's the chlorine gas, and we have this, the other one, we have some kind of salt, some kind of, or some parts of sodium. That's what that appears in the negative pole. After that, we have the conductors and doesn't conduct which one? That's electricity. We have sodium chloride solution, it's conduct or not. We have what? We have this is conduct electric energy, it's an electrolyte. And other one, molten red bromide, it's conduct electric energy. Because what? Because it is molten state in liquid state, so it is another electrolyte. And we have solid copper sulfate, doesn't conduct here. Excellent. Why? Because copper sulfate in solid material, it is ionic material or ionic compound, but has no free ions to conduct electric energy. It is not electrolyte. And we have copper sulfate solution, also conduct electric energy. Solid lead bromide doesn't make any conduction. Molten aluminum oxide It makes what? It makes conduction. Sodium chloride crystals in solid. It's what? It's the correction. So they are, all of them are right. Well done. We have electrolysis of molten lead bromide. Electrolysis here, it means what? It means a type of material that make electrolysis or separation or purification of some kind of compounds from what? From its material or from its compound. I need to separate elements from its compound. Let's go to C. We have number 1, the molten ionic one. Stage number 1, when molten lead bromide, for example, or any type of these compounds that conduct electricity, it's split into its elements. So the positive, and we have negative. I turn on this battery and the lamp will light up, so we have the electric energy that passes from the inside this circuit, because the lead bromide in molten state, it's what? It is conductor, it is an electrolyte also. Bromine gas, it formed at the positive electrode as we see here. Okay, after that we have stage number 2, the ions of lead that move freely like the first one. So here are free to move when it's molten. They are attached to the electrodes where the redox reaction occur that happened from at each what? At each type of electrode. Which type of electrode? That reaction, what's happened of each one of these electrodes. We have number 3, the positive lead ion, okay, that move to what? To the electrode number, or the electrode, the negative electrode. So here the pp2 ions that change and take or gain the electrons from this pool and change into atom that prepare or that precipitate in the bottom part of what? Of the container. After that we have the negative bromide. It makes what? It makes this bromide, it makes the losing electrons and move with each other as what? As the ions of bromine. That's what? Or bromide ions that lose electrons and makes what? Lose electric charges and makes what? And move away from each other to forming what? Forming one molecule of the Br2 or bromine molecules like this. After that, the redox process. What's meant by redox? Redox reaction, it means the oxidation reduction reaction. What's meant by oxidation? Oxidation here, it means losing electron and change or increase the positive ion or the positive charge on the atom. Excellent. But here we have the oxidation and here we have the reduction. What's meant by reduction here? Reduction, it means the gaining electrons from the atom and increasing the negative charge or decreasing of the positive charge. So here we have the lead bromide change into lead and bromine, but here pp Br2 liquid state or molten state change into pp liquid state and what? Plus Br2 gas. So this is bromine gas and here we have the pp liquid state, okay, in small amount like this. After that we have an application to find out the aluminum extracted by electrolysis. We have this type of compounds that we use it Al2O3 and we have bauxite, it's named bauxite, and the main ore of aluminum. I need to extract or separate the aluminum from these oxides. Let's go to see this electrolysis of this compound in a molten state. Let's go to see the first one or the first stage. We have first stage, the electrolysis of what? Of the aluminum oxide takes place in the steel tank. It made of what? Made of steel and lining with what? Inside its container we have the graphite blocks that found in positive electrode or connected to the positive electrode, and we have the graphite lining, that negative electrode. So here the negative and positive connected to the source of electric energy, high voltage, and here the graphite lining, the negative electrode. So here this lining as the negative electrode, graphite blocks at the positive electrode. So the electrolysis of the aluminum oxide takes place in a steel tank lined with graphite. After that we have aluminum oxide is dissolved in a molten cryolite. Again, aluminum oxide is dissolved in the molten Cryolite. Cryolite, it means the compound here that used to make this reaction or to help us to make this reaction. And we have the aluminum positive 3 and O2, O minus 2. It's ion of oxygen and the ions of aluminum. That's freely movement inside the compound in molten state. So what happened when the current passed through these molten electrolytes? After that, stage number 3, when the current is switched on, the molten aluminum forms at the negative electrode at the bottom of the tank. Again, we have when the oxygen is formed here as a bubbles here on the positive electrode of graphite, and we have the molten aluminum forms negative electrode here or collected at the negative electrode because it is positive ions of aluminum. It's positive 3. So the positive ions collected in the molten state with the negative pole or negative electrode, and the positive electrode collect the oxygen as what? As negative ion. So stage 3 again, when the current is switched on, molten aluminum forms at the negative electrode at the bottom of the tank, and the oxygen formed at the positive electrodes. How are these products formed? We see stage number 4. The positive Al, positive 3 ions, they are what? They are collected here, and we have this one that gain electron and change into aluminum atom like this, like we see in this shape. So the aluminum ions that's gain electron and changed into atoms. So these atoms, it moves and precipitate in the last part of this tank. So then positive Al, positive 3 ions are attached to the negative electrode. They gain electron to become aluminum atom, forming liquid metal at the bottom of the tank due to the high voltage of electric energy that it changed into heat energy. So it is reduction process. After that, we have the negative O2 or negative ions of oxygen that makes attached to the positive electrode. They lose electrons and becomes oxygen. Again, the atoms or ions of oxygen, that's what collected at the electrodes of positive electrode on in this tank to make what? To make gaining electrons, or it's what? Losing electrons of this one of the ions, and they change into atoms of oxygen to form O2 in each one of them. So it is like what? Like Br2. Gain its lose electrons and what? And they change into gaseous state that formed this one, which form oxygen molecule and they give off its gas. It's called oxidation process. After that, we have the hot conditions. The oxygen formed at the positive electrode react with graphite from the carbon oxide. To form carbon dioxide, graphite react with oxygen forming carbon dioxide. And after that, the graphite gradually wears away from these electrodes, eventually have to be replaced. After that, in stage 7, the last one, we have solid crust of the aluminum oxide that appears. The surface of the coolest one or coolest part of the hot molten electrolyte, and the crust of aluminum oxide forms here. So the pure molten aluminum formed at what? At the bottom of the tank in one of the intervals. So the pure aluminum collected what? Collected in the bottom of this one and moved through the pipe to another container, and we use it in the industry to make many shapes of this aluminum. It's very easy and very important to know how is aluminum extracted by electrolysis. Now we have another activity. We have what? We have electrolysis. How is the copper purified by electrolysis? Copper is purified by electrolysis as we see now. Electrolysis is used to remove any impurities from the copper, so they pure through what? Enough for making electrical wires. We use this copper, or we use this method to make copper is more pure to use it in the wires, to make electric wires. Let's go to see the first part or the first thing about this first stage. We have what? We have Stage 1, positive electrode, that impure copper. Impure, it is commercial copper that contains some impurities like metals, like gold, like silver, like anything of this. And we have the other one, or the negative electrode, is pure copper. Pure copper, we have this one, or this copper, 96,500. So after that we have an example or problem. This problem tell us what? How many minutes are necessary for the following to happen? Again, how many minutes are necessary for the following to happen? Production of 10,500 coulombs from current of 25 amperes strength. It's very easy to know. It's nearly to physics. We have the need, I need to calculate how many minutes for what? Of 10,500 coulombs from the current of 25 amperes strength. What the answer? The answer here, electric current equal I, or I equal Q divide T. So the T is the time, represents time, equal Q, the quantity of electric energy, by coulomb, divide I, it's the electric current by ampere. Again, time equal what? Equal quantity of electric energy by coulomb, or quantity of charges, divide what? Divide amperes, electric current by amperes. Equal what? Equal the time equal 10,500 divide 25 amperes. So 25 amperes, and we have 10,500 coulombs. Divide each other, that form 420 seconds. Again, 420 seconds. I need, this is the time, it is right, very good, but I need it in minutes. So the minutes here, we have 420 seconds divide 60, because each minute contains 60 seconds, equal what? Equal 7 minutes to make this reaction. It's very easy, it's very important to know this one. After that, we have another example or another problem. What are the masses of gold and chlorine that produced from passing 10,000 coulombs of resulted electricity in aqueous gold chloride solution? I need the mass of each one, gold and chlorine, of each one of these compound that's found in the following reaction. The following reaction is what? Is Au positive 3, that make gaining 3 electrons change it into atoms of gold. Again, Au is the gold atom or ion of gold positive 3 plus 3 electrons that gained by this ion to change it into Au atoms. And the chlorine 2 Cl negative, that gives us Cl2 plus 2 electron by losing electron. Which one is reduction? Which one is oxidation? Yes, excellent. The first one, gaining electron, it means reduction. And the second one, it is oxidation. So the oxidation here, it's happened on what? On the atom or ion of chlorine. And the reduction that's happened with what? With the ion of what? Ion of gold. After that, we have the answer here. Equivalent mass of gold equal what? Equal the mass number or the atomic mass divide what? Divide the valency of gold. So here the valency, and here we have 196.98 divide 3 equal what? Equal 65.6631 gram. You must write the number as it is by calculation to make it very right. Because what? Because every one of these number don't make approximation of this number from the first step. Answer is right. So after that, 35.45 divide what? Divide 1 equal 30. It's very easy to know the equivalent mass. لازم الأول أحسب كل أتوم أو في كل أين اللي أنا عايزه علشان أقدر أحط أو أقدر أطلع ويكون صح إن شاء الله، أقدر أعوض بيه في البروبلم بتاعتي ويطلع لي result مظبوط. Let's go to see the other step. The mass of deposited gold equal 10,000 what? 10,000 coulomb times what? Times 6 65.66 divided by 96,500 equal 6. Make this one 65.66. This comes out from the equivalent mass of gold, and we have 10,000. So here this is what? This is the 6.8 gram. And we have another one, the mass of deposited chlorine, 35.45 times 10,000 divided by what? 35.45 gram. It's very easy to know these answers and to answer this type of problems. Another example, what is the quantity of electricity necessary for separation of 5.6 gram of what? Of iron 3 chloride. Again, what is the quantity of electricity I need? How many coulombs that's used or necessary for separation of 5.6 grams of iron 3 chloride, where the cathode or negative charge reaction will be as the following. What is the reaction here? We have Fe positive 3 that gain 3 electrons to give us Fe atoms. So the Fe it given as 55.68. So the iron molecular mass of iron is what? 55.68. So I need to calculate how many coulombs that used to make this reaction. What will happen after that? We have the answer here, equivalent mass of iron. It is very easy. It is very important to calculate the equivalent mass in this C. So the atomic mass divide the valency equal what? Equal 55.68 divide 3. It's equal 18.68 gram. It's the equivalent mass of iron. And replace this one in the rule. We have the mass of deposited iron. We have 6.5 times 96,500 divide 18.62. So equal to, it's 29022, okay, 0.5 coulombs. It's very easy to answer this type of problems. Again, in last time we have the mass of deposited iron 6.5 that comes out from what? From the problem, and 96,500 divide 18.62. It is the equivalent mass of what? Of this atom of iron that gives us the number of coulombs that produced by or that needed to make this reaction. So we have another question. What is the salt bridge? What is the importance of it in the galvanic cells? It's very important question here. So this one is salt bridge. It's U-shaped glass tube filled with salt solution, NaCl or Na2SO4 or potassium chloride, any type of salt. That's what that salt bridge is, the U-shaped glass tube filled with the salt solution, by which its ion don't react with ions of the two halves of the cell, as well as with electrode materials. So the importance of salt bridge, number one, it connects between two halves of the cell without allowing the direct connection between them or direct contact between them. So the second one, we have the neutralized poles of the positive and negative ions, which form the solution of two halves of the cell. Dear friends, I hope to enjoy your time with us. It's very important to revise your questions in this part, in this term of electrochemistry, very well to answer your questions in the exam in a right way. Till we meet again in another session about revision, till we meet again, thank you and goodbye everybody.